Alright, so the second half of the homework here, again, this is going to relate to quadratics, but what we see here is we have something that can be transformed into a quadratic even though it is something of degree 4 at the moment, right? So we're trying to solve this x to the 4th minus 40x squared plus 144 equals 0. So the point is, since there's no x cubed term, we could let another variable y represent x squared, and then it will change into something that looks like a quadratic. So if I let y equal x squared, then that also means that y squared would be x to the 4th. So we can substitute. So that x to the 4th will now become y squared, and the x squared will become y, and we just have the plus 144. There's no x to replace there. So then we either need to factor it or use the quadratic formula. If it factors, it would have to be two negatives. So 144 is 12 times 12, so there's a lot of choices. Was that 36 times 4? 36 times 4 looks like it works, right? So this would factor into y minus 36 times y minus 4 equals 0, right? Because negative 36 times negative 4 is positive 144, and if you add the negative 6 and the negative 4, you get negative 40. So this gives us two answers here, y equals 36 or y equals 4. But remember, the original problem is not asking what y is, it's asking what you started with. X, what is that? So we need to transform that y back into x squared and then solve that resulting equation. So if we end up with x squared equals 36 or x squared equals 4, then we can use the square root property to solve for x in both of those. So that's what we do. We have x squared equals 36 or x squared equals 4, and then by the square root property that would mean x is plus or minus the square root of 36, which is 6, or x is plus or minus the square root of 4, which is 2. So we get 4 answers there, plus or minus 6 or plus or minus 2. And that's it. Any questions on that one? So it kind of combines some of the strategies. We just have to start off with the substitution. And it's going to be the similar thing here. Again, what you're going to want to let y be is the smaller of the two. If y is x to the 1/3, if you square it, you get x to the 2/3. So this problem is going to be very similar. So let's go ahead and do that substitution. So we have 4x to the 2/3 minus 35x to the 1/3 minus 9 equals 0. So we let y be x to the 1/3, which means y squared is x to the 2/3. So this means 4y squared minus 35y minus 9 equals 0. So again, this is one of the harder case because the coefficient of y squared is not just 1. So we have to factor this by grouping. So if you multiply the 4 and the minus 9, you get negative 36. And then we want two numbers that multiply to minus 36 but add to 35. So that can be, say, 1 and minus 36. So we can just break this into 4y squared plus y minus 36y minus 9 equals 0. So we factor by grouping. The first two you can take out a y, and you get 4y plus 1. And then the second group you can take out a negative 9, and you'll get that 4y plus 1 again. And so then we get our y minus 9 times 4y plus 1 equals 0. Factoring as usual. So y is either equal to 9 here or negative 1/4. And then you replace it with the original thing. So if x is the cube root, so x to the 1/3 equals 9. or x to the 1/3 equals minus 1/4. You can cube both sides. So, right, x would be 9 to the 3rd power, or x would be negative 1/4 to the 3rd power. Right, you're just raising both sides to the 3rd power. So this x I know will come out to negative 164, negative 1 over 64. What's the other one if you cube it? 81 times 9, 729. Yeah. So we'll see if we got it right. So minus 1 over 64, or 729. Yeah, so we got it. So the same exact process, but instead of letting y be x squared, this time we let y be x to the 1/3. And then instead of doing the square root property at the end, we just raised both sides to the 3rd power to solve for x. Okay, absolute value equations are pretty easy. The main point here is if you have the algebraic, the absolute value of some expression, let's say some algebraic expression, capital A equals some number. The way that you solve this is there's two possibilities, right? If you had the absolute value of something equals 7, well, then the original thing could have either been 7 or negative 7. Because absolute value has two things that would give the same value because it just removes the negative. Another way to think about absolute value is total distance from 0. So if you would say, what's 5 units from 0? Well, to the right is positive 5, to the left is negative 5. They're both 5 units away from 0. So the way you solve this is A is equal to the number, or A is equal to the opposite of the number. So that's exactly what we'll see here. If we have the absolute value of x minus 9 is equal to 5, this just becomes two different equations. We get x minus 9 equals 5, or x minus 9 equals minus 5, and we just solve both of these. So we add 9 to both sides to solve, so x is equal to 14, or x is equal to positive 4. And those are your two solutions. So an absolute value equation just breaks down into two different equations. That's all there is to it. So 4 and 14. Any questions on that? So that's the setup every time. So if you do have a bunch of junk on one side, one point to make is you want to isolate that absolute value before you do that step that turns it into two equations. So you have to isolate it the same way we try and isolate variables when we're solving linear equations. Same here, so go through the same rigmarole. So we have the absolute value of 2x minus 1 equals 3. So we have 2x minus 1 equals negative 3, or 2x minus 1 is equal to positive 3. So add 1 to both sides, so 2x would equal negative 2, or 2x would equal 4, and then just divide by 2. So we get x equals minus 1, or x is equal to 2. So negative 1 and 2. Expressing the interval and set builder notation. So we've gone over interval notation in here when we did inequalities, right? Yes, I believe so. So set builder notation is just basically set builder notation looks like this. So it's a set, so it's going to be in these squiggly braces, and it's going to be x, and then a bar, and then we have some condition. So this is essentially the variable name, This bar just means literally such that. So that's essentially saying it stipulates this condition. So this is the variable under these stipulations, and that is what narrows the set down. So this is the essentially the limiting conditions. Right? It's the specifications that require you belong to this group. So for many things, so for this one, -7, 0, it may help you to think about the graph, right? On the graph, you have like -7 here, you have 0. So we're including 0, we're not including -7. -7 is just a boundary value, meaning you can get close to it, but it's not including that value. So basically, if you think about a variable, it's just saying, okay, that variable has to be bigger than -7, smaller than or equal to 0. So this is like our limiting condition. So in set builder notation, it's essentially finding this inequality, but just writing it as x such that -7 is less than x is less than or equal to 0. Is that clear? So it's a little more formal than just writing down the inequality. Oh, so it's like this, less equals. Okay. 0. That's it. Not so difficult. Okay, then the graph, which we've already done. Are there more options? Oh, it's this one, C. So rather than using the rounded dot and the shaded dot, they're just using the grouping symbols that we have from the interval notation. So notice that this rounded symbol matches up with the open dot, and the square bracket matches up with the shaded dot. Okay, so number 22 here is just going to be a one-sided graph. So we have 2, infinity. So the graph, we're just looking for all the numbers, including 2, that happen to be bigger than 2. So that just means x is bigger than or equal to 2. So this reads x such that x is greater than or equal to 2. Does anybody know what the symbol, the infinity symbol, is called? So here's just like a little bit of trivia. What is the formal name for the infinity symbol? So I'll just write it out here. Anybody happen to know? If you've ever had algebra or calculus where you took polar coordinates, anybody ever done polar graphs? So sometimes you can graph this polar graph and you get this shape. This shape is known as lemniscate. So maybe one day you'll answer a trivia question right because of that. It's kind of a cool name. Alright. And the graph was 2 and larger, including 2. Okay. So again, we're looking at intersection and union. We saw some of this in either Module 1 or Module 2 in the prerequisite modules. There was quite a lot going on though, so I'll just remind you what these symbols mean. There's 2 important symbols for adjoining sets, putting them together. So this is intersection, and this means things common to both sets. And then we also have the other operator, the so-called union operator. So these are anything in one set, the other set, or both sets. Okay, so those are the two ways you can kind of put sets together. So we have -5, 6 intersect -4, 7. So I don't know, maybe I could take advantage of all these colors I've got here. So we've got -5. I'm not necessarily drawing this to scale, you know, it's just important to see where they overlap. And then we have 6 and we have 7. So I don't know, let's use, what is this, blue? So blue, so we'll do the first set in blue, -5 up to 6. Right, and then you have, we'll do red for -4 to 7. So that would be -4 up to 7. And you could imagine the intersection has to be all the things that are colored both red and blue. So if you mixed all the colors together, these would be the things that would come out purple. So the things that are colored by both are going to be starting at -4 and including -4 up until we get to 6. But it does not include 6 because 6 is not colored. So this would be, that's the set. We don't have to write set builder notation for this one. Any questions there? Okay, so now we have a union problem. So we have -4, 7 up until -1, 8. So these are just going to be the things that are included in both. So we have a -4, a -1, a 7, and an 8. So -4 to 7 is here to here, and -1 to 8 is here to here. And what does the union mean? It means take anybody that's colored by anything. Does that make sense? It has to be either colored red or colored blue or colored both. That's what the union says. So we take anybody that's colored anything. So we would go from -4 all the way over here to 8. And -4 is not colored by anybody, it's just a boundary point. But 8 is colored red, so we include 8. Does that make sense? Okay, then we have some interval notation problems, so we're just solving the inequality. Remember, for solving these inequalities, they work exactly the same as solving problems. The only difference is if you multiply or divide by a negative, right? If you multiply or divide by a negative at any point, what do you have to do? Flip the direction of the sign of the inequality symbols. So we'll see when that comes up. A lot of times you can avoid it just by choosing to add appropriately, keeping the coefficient of x positive. So 2x plus 4 greater than 10. So we just subtract 4 on both sides. So we have 2x is greater than 6. Then we divide by 2. So we get x is bigger than 3. Again, if you want to graph that, that's just everybody bigger than 3. So we're just shading to the right. Bigger numbers are to the right. In interval notation, this would be from 3 all the way up to infinity. And then we see, it's kind of funny that they do the interval notation first, because at least if you're a visual learner, you would normally do the graph, and then you can kind of see how the graph corresponds to the interval. The intervals are just kind of like bookends, with the farthest thing to the left and the farthest thing to the right. That's how I think about it. Okay, so number 26 here is designed for us to remember that fact about flipping the direction of the inequality sign. So negative 4x less than or equal to 32. So I guess we could say caveat here. I don't know why we always have to use like Latin when we do things. Do you guys know what caveat means? It's just a Latin word meaning warning. I don't know why. I guess I could write warning or beware or something like that. But, you know, they always like to use Latin words. This is technically in the subjunctive mood, so it means it implies necessity. Anyhow, so the most famous place you've probably heard this before, if you've ever heard the phrase caveat emptor, that means let the buyer beware. Anyway, so I just want to note that when we multiply or divide an inequality using a negative, we must flip the direction of any inequality symbols. So we have this negative 4x less than or equal to 32. So the only thing we're doing to x is currently multiplying it by negative 4. So we divide by negative 4, and we flip the direction of that less than or equal to. So less than or equal to will become greater than or equal to. So we get x is greater than or equal to negative 8. And right, we have negative 8. We shade, and we're picking things that are larger. So this is going to be negative 8 up to infinity. Everyone clear on that? Then we have to graph it, so C. Okay, and then all the other inequality symbols work the same. It's just similar to solving equations, right? You have to distribute to get rid of all parentheses, add your like terms, isolate x, and then multiply or divide by the appropriate number. So there's really nothing new here. It's just a little bit of a longer problem than number 26. So number 27, we have 7 times the quantity 6x minus 1 minus 6x less than 6 times the quantity 3 plus 6x minus 7. So I have two things I need to distribute. I need to distribute the 7 on the left-hand side and the 6 on the right-hand side. So I have 42x minus 7 minus 6x is less than 18 plus 36x minus 7. So on the left I can add 42 minus 6x. So that gives me 36x minus 7. And this is less than 36x plus 11. Okay, so then what I can do if I try to combine my x's, I could subtract 36x on both sides, but then all the x's go away and I end up with minus 7 is less than 11. Yeah, minus 7 is less than 11. Okay, so the first question is that true? Is minus 7 less than 11? Yes, that is true. So if you go back a step previous, would that be true if you put in any value of x? So if you put in x equals 0, you get negative 7 is less than 11. That's true. If you would put in x equals 1, you would get 29 is less than 47. That would be true. It's true for any value of x that you plug in. So your solution set here is actually going to be all real numbers. And the interval notation for that is pretty easy. It's just negative infinity all the way up to infinity. That's all. And so that's just everything shaded, which would be B. Okay, so a compound inequality has 3 parts. Same rules apply. You just try and isolate x. Usually it's going to be in the middle, or eventually will be in the middle. And if you happen to need to multiply or divide by a negative, then you would have to flip both inequality symbols. So anything you do to one part, you have to do to all 3 parts here. So we're doing 2 things to x. We're subtracting 2 and multiplying by 2. So we first add 2 to get rid of the minus 2. So we have minus 6 less than 2x less than or equal to 6. What am I talking about? Then we divide by the 2. So we get minus 3 less than x less than or equal to 3. And again, that's a pretty easy interval notation, negative 3, comma 3, with a square bracket near the 3. Okay, so absolute value inequalities. There's 2 possible cases. Again, it's helpful to think of this as distance from 0. So number 29. So absolute value inequalities. So we have 2 cases. So case 1, we'll say here you have the absolute value of some algebraic expression less than or equal to 4. So in general, it's not less than or equal to 4. It's actually less than or equal to some positive number. And what this breaks down to is this breaks down to negative a less than or equal to the number less than or equal to a. And if it were less than, you would remove the bottom equal symbol. Right? This problem that we're looking at here is saying x plus 9 is less than a distance of 4, right? So if it's less than a distance of 4, you have to be between, if we're talking about from 0, you have to be between negative 4, which is 4 to the left, and positive 4, which is 4 to the right. Now the other case, let's say we had absolute value of a bigger than or equal to a number. Well, then this is going to have 2 possible outcomes, right? Because now, instead of being less than 4, you have to be, let's say you were greater than or equal to 5. Then you would have to be farther than 5 away from 0. So you would have to be past 5, or you would have to be less than negative 5, right? You have to be farther away than those 2 points. So you're going to have to be less than or equal to the negative number, or bigger than or equal to the positive number. So you get an OR case here. So for the first one, you get a compound. For the second one, you get an OR. So you would have the number less than or equal to negative a, or the number bigger than or equal to a. So for this first one, we're in case 1. We have x plus 9 less than or equal to 4. So this is case 1. So we have negative 4 less than or equal to x plus 9 less than or equal to positive 4. So that's all we have to do is subtract 9 from all three parts. So we have minus 13 less than or equal to x less than or equal to minus 5, which is negative 13 comma negative 5. All right. Now again, number 30 here looks a little bit more difficult, but it still is just case 1, right? You have an algebraic expression, the absolute value of an algebraic expression less than or equal to some number. In this case, 6. So we have number 30. So the absolute value of 4 times, I put the parenthesis in the wrong spot. 4 times the absolute value of x minus 1 plus 6 less than or equal to 6. Okay, so we can do the two cases immediately. 4 times absolute value, again I'll note that this is case 1. X minus 1 plus 6 less than or equal to minus 6. Or 4 times x minus 1 plus 6 less than or equal to 6. Oh, what am I doing? I did case 2. Compound. Sorry. I said one thing and did another one. So minus 6 should be less than or equal to this 4 times x minus 1 plus 6 less than or equal to positive 6. So it's a compound inequality. Sorry about that. Case 2 is the or. Okay, so let's simplify in the middle. So we have negative 6 less than or equal to 4x minus 4 plus 6 less than or equal to 6. So the negative 4 and the positive 6 in the middle add to 2. So minus 6 less than or equal to 4x plus 2 less than or equal to 6. So the last two steps are going to be subtract 2 and then divide by 4. So we subtract 2. Get minus 8 less than or equal to 4x less than or equal to 4. And then divide all three parts by 4. So we have minus 2 less than or equal to x less than or equal to 1. So we have minus 2 comma 1 is our answer. Just curious better. Oh, I did similar. I meant to go to the next. Okay, so here we just have a word problem, but it's going to be used by an inequality essentially. So let's see how to set this up. So again, I like to parse these problems. I don't like to read them through directly. So a lot of times declaration of variable can be determined by just looking at the question or the last sentence. So in this case, how many bags of cement can be lifted on the elevator in one trip? I'm just going to call x the number of bags of cement. So let x be the number of bags of cement. And then as I read the problem, if I have enough information to write down an equation, it makes it easier to do. So we have an elevator construction site with a maximum capacity of 2285 pounds. So in my head, I'm already thinking something is going to be less than or equal to 2285. So if the elevator operator raised 205 and each bag of cement is 80, how many bags can be safely lifted? Okay, well, I've got my operator 205 plus my number of 80-pound bags. So that's 80 pounds times x. I want this to be less than or equal to 2285. So this is the inequality to solve. So I subtract 205. So I get 80x is less than or equal to 2085. Is that right? 2080. Excuse me. Oh, so 5 is 4, 20. So what? 26. So 26 would be the maximum if I did my mental math right. Yeah. Okay, so that's it for the inequalities here. Are there any questions on any of the problems we've done tonight? Okay, and then the learning guide that we looked at is just a bunch of videos and then answering questions on the videos. And I guess that's it. So let me do the attendance, and then you can stick around if you have any questions.